Nissan's S13 is probably one of the more popular cars for modification, and no doubt there's a bunch of them all around the world running an LS engine, but the one behind me is the first one I've ever seen with a roots blower strapped on top of an LS. We're here with Mitch from Pullen Spec Engines to find out a little bit more about this specific build. So for a start, Mitch, I got to ask, why the LS when there's so many other import engines that are popular for fitting into an S13 chassis?
Well, we've sort of grown up doing LSs and did some GT3 cars and all that sort of stuff, so LSs have always made sense. Then this Silvia here made sense, so we put it all together.
Okay, that's fine, and I mean, I can't argue. The LS is a great platform, it's well proven, relatively cost effective to get good power out of, and reliable, so all that makes sense. The roots blower though is the part that I'm most interested in. I would say, and I mean this might be a little controversial, in this day and age the roots blower is maybe not the best form of forced induction. It's known to be relatively inefficient, so why did you go down that path?
Oh, it just looks cool, doesn't it? I mean,
can't argue with that.
Yeah, so it is inefficient, and if you've seen the VE table, you'd see how inefficient it is, as I'm sure you can imagine. But it's just cool, sounds cool, idles cranky, and it sort of shouldn't work, should it? So the fact that we've got it working pretty good is what makes it cool as well.
There are a few considerations with EFI on a root style blower, and I'm interested to dive into how you're dealing with that. Before we get into the specifics of that, let's look at a bit of a high level view. What is the electronics platform you're using? What is the ECU?
Yeah, so it's got a Haltech NEXUS R5, and then we've got individual EGTs going into that as well, and that's pretty well, the R5 does so much stuff, it's pretty well all we need.
So with that R5, I know that it encompasses engine control as well as power distribution module built into the same box. Are you utilising that to run the electronics power supply?
Yeah, we've pretty well maxed out all the HCO outputs and everything. And then we've got a CAN keypad and stuff as well, so we're flashing lights with pit lane limiters and just a bit of cool stuff, you know.
All the things you can do when you've got a power distribution module at your fingertips.
Yeah, 100%, and it all just integrates so well. I just sit on the laptop and start getting ideas what I can make happen. Next minute, we've got some generic tables doing it, and away we go.
Now, back to this blower. Conventionally, we might see maybe a carburetor or a couple of carburetors stuck on top of the blower, and the fuel obviously therefore gets introduced before the actual roots blower itself. However, with EFI, really if we want good control, we want multi-point injection with an injector mounted down by each inlet runner, and that's obviously how the LS is in stock form. How have you dealt with fuel delivery in this particular platform?
So it's got 16 injectors in total, which the R5's got 16 drivers. It can run them sequentially if you'd like. Up the top, we've got 1360cc injectors, which are doing about, depending where you are in the map, 90 to 95% of all the fueling. So that's all our intercooling as well. So as that comes through the blower, it does a bit of lubrication, but mainly cooling is the biggest part. Then we've got a set of 450cc's down the bottom, which are mainly used for just individual cylinder trimming, and we're using them a little bit on transient as well.
Right, there's a bunch of things we'll dive into in a bit more detail there. So first of all, you mentioned intercooling. So this is non-intercooled, so you're using the fuel itself as effectively liquid intercooling?
Yep, yeah, that's correct. So we're running it sort of as fat as we can get away with, sort of thing, in a basic sort of terminology, which is about 0.80 with not a lot of boost. It's definitely on the fat side. And intake air temps wise, it's like 50 degrees, 45 degrees, depending on the temp of the day. So I think the secret to that is just not spinning the blower too fast and just as efficient as it can be in such an inefficient package.
Let's just come back to that efficiency. I've mentioned earlier that the roots blower is not a particularly efficient way of, or method of forced induction. And what we're talking about there is when we compress air, naturally physics says that we're going to heat it up. But then depending on the efficiency of the particular forced induction method, supercharger, root style blower or screw style blower, then depending on how efficient that is, that also adds more heat. The more inefficient it is, the hotter the air temperature gets.
Yeah.
So that's what we're talking about there. A big element of that, you talk about slowing the supercharger down. Obviously this also impacts on the actual boost pressure that the supercharger will make. So what boost are you using?
So it ramps up as the RPM comes up, but a maximum about, depending on the day, 7.5, 8 pounds is all it's got. And I have tried it with more, and it'll make more power down low, but we just hit like a brick wall eventually, yeah.
Yeah, all right, makes sense. So relatively low boost, but still, even 7 PSI without an intercooler, the intake temperatures are absolutely going to be up there. So the fuel is obviously working. The other element, as I understand it, and I'll be honest here, my experience with actually tuning root style blowers is relatively limited, but I understand that introducing the fuel pre-supercharger also has an effect of basically almost sealing up the gaps between the lobes and improving the efficiency that way.
Yeah, this is my first blown combo as well, so I'm not probably an expert on it, but I've done as much reading as I can to understand what I can. But definitely would make a difference there for sure. And then methanol, again, it'd be just probably tenfold above that again as far as sealing up and all that as well.
On that basis, I'm assuming you're not running methanol in this application though?
Nah, just E85. Yeah, we might look at methanol one day, but E85 currently.
Now, getting back to the injectors above the supercharger, we've talked about why they're necessary. My assumption here, though, would be introducing all of the fuel above the supercharger. You're going to have maybe less than ideal mixture formation, and you're going to get inconsistencies in the mixture on each cylinder. Is that actually the case, and is that why you're using the lower injectors to trim?
Yeah, well, it is to an extent, but it's actually surprising. The lower, like the cylinders, are within about 8% overall, as far as from the leanest to the richest, in regards to EGTs, as far as getting all that similar. So not as bad as you would think.
Well, let's just talk about those EGTs. I mean, this has long been a really good form of monitoring essentially individual cylinder air-fuel ratios indirectly. Obviously, it's not the air-fuel ratio, but the idea here is that as the air-fuel ratio goes richer or leaner, we end up with the combustion temperature changing and therefore the exhaust gas temperature changing. So we're sort of getting an indirect view into what's going on in the combustion chamber. It's not quite the same as individual cylinder lambda, but in terms of fuel trimming, it's long been a really good method. So how are you using those, and how are you using the Nexus then to make these changes? And last question on that, what sort of variation cylinder to cylinder in terms of EGT are you looking for?
Yeah, so I've got obviously a bit of a baseline from when we're on the dyno of where they get to. So I'll give it as much of a hard time as we can on the dyno. Then I've got some individual cylinder trims just based on EGT. So if it gets above that every 25 degrees, I throw some more fuel at it. And then from logs and stuff, there's a couple cylinders that always seem to be colder or hotter than the main bunch. So they're just got in those same tables. I just pulled a bit out, I added a bit just overall. And that's pretty well there. And then as far as all the temperatures, it sort of gets to mid 700s is as high as we really see it. And then within sort of 15 to 20 degrees over the whole set.
I'd say mid 700s. I mean, the EGTs on E85 always colder than pump fuel, but that I would have said was probably still relatively cold.
Yeah, it seems I haven't done that much with EGT, especially in a blown combination. Like on the actual dyno, where it's obviously just that one pull, we're lucky to hit 700. But after you give it some limiter and there's fire coming out the exhaust and that, 750 is about it. 775 is the highest I've seen, which it did have carbies before, and they were heaps higher. Yep.
Are there any other sort of irregularities that come into the tuning strategy when you're dealing with this quite unusual combination? Anything around sort of transient enrichment for acceleration enrichment, deceleration enlightenment that are challenging? Yeah,
there's a couple of things. So transient, as everyone can imagine, is a big thing because you're injecting a lot of the fuel above the blower and it's got to get there, even though the air's coming with it. So they're sort of friends, I guess, in a way, but there's definitely a lot in that. It takes a lot of transient. That's one thing. Another thing interesting is that acceleration in lean. Acceleration in lean, not that. So when you back off the throttle, this is all tuned map based, not TPS based. When you snap off the throttle, it keeps making boosts for like a couple tenths of seconds, which obviously the engine doesn't want it. So it was getting really fat when I backed off. So I've got a table set up as well, TPS over RPM, just simple TPS RPM table, which just pulling fuel out. So in a low throttle percentage high boost, it's not really happening. It's sort of false, I guess we could say. It is.
You've kind of got a few workarounds that you're doing to sort of get a combination that's maybe not ideally suited to conventional multi-point fuel injection to actually work.
Yeah, just a couple of them weird things, and it's just stuff we keep learning more and more, just going through the logging of where they're happening and what we can do about it, but we're pretty well on top of it now. And one other thing we see is, and I can't explain this probably yet, I'm still understanding it, is depending on the load or the acceleration rate of the engine. So if the engine can accelerate freely, so a low grip or low gear application, it's fairly easy and fairly linear what you've got going on as far as the fueling. But when it gets to a point where it's really loaded and it can't just get itself to the limiter, it needs, even though your map's the same, your RPM's the same, everything's the same, it seems to need a lot more fuel. So there must be some evaporation stuff going on, I guess.
Are you using anything like closed-loop fuel control to sort of pick up the pieces in those weird situations where everything's not quite mapping out how it conventionally should?
Yeah, so what I did was, we've only done a couple track days since it's had the injection, and the last track day was when we could finally get on the big track. So from the logs, I just put the effort into getting it tuned up for when it's in grip and when it wants the fuel. So that's what our base numbers are now. And then we've just got fairly aggressive short-term fuel trims to, if you're under less load and it's a bit fat, it can pull it out, sort of thing.
I mean, ultimately, when it's really loaded up, that's where you want to make sure that you're on point. You don't want to be lean under those conditions, whereas if it's sort of free revving up to the limiter, a little bit less critical.
Yeah, 100%. And because the dyno, I did it on a fairly fast ramp rate as well, and then the original testing we done, it was perfect, and it wasn't until I loaded it up, I was like, hey, this thing's going lean. So then it just made sense to, obviously, the high load application, have it correct then, and rely on the short term whenever else.
All right, well, I think we've done the injection side of things now. Let's talk about the rest of the engine sitting underneath it. So what is this LS combination? Obviously, there's a bunch of options.
Yeah, so I guess it's LS-based, I guess we can say. It's a 3.25-inch stroke crank inside a dart block with a 6.3-inch Callie's rod and a CP piston. And it's a big bore as well. We're 4.125 bore, which comes out to like a 5.7 litre or 350 cubes, but nothing like a traditional LS 5.7 litre.
Yeah, so you've gone quite a different route with the engine architecture in terms of bigger bore but shorter stroke to still end up at essentially an LS1 capacity. Why that shorter stroke? What's the critical element there? Is this about engine RPM capability?
Yeah, so engine RPM capability is a big part, and obviously if you want to rev something and horsepower, obviously we can make power, that's not an issue. It's revving the thing reliably and not having dramas and getting rid of that rod angle and getting rid of as much piston speed as we can, because we don't need the piston speed to excite the port or anything. We're using the blower for that. So just reliability more than anything.
Rod angle, so this is something that a lot of people kind of overlook, and it really comes down to the rod to stroke ratio, which here you've improved. Can you talk us through what's critical with the rod to stroke ratio?
Well, if you got, say, a common stroker LS, which is everyone's got them, what ends up, there's a couple things that happen. One thing, if it's in a factory style block, it pulls the piston out the bottom of the bore, so that's one issue. Then the other drama is when it's in the middle of its stroke, there's a fairly aggressive rod angle there. I don't have the numbers right off the top of my head, but it's fairly, so if you think of it, the rod's trying to push the piston out the side of the block. Whereas when you've got a short stroke and then a longer rod, it's sort of a longer lever, I guess. There's a couple ways to explain it, but as the longer you make that rod, there's less of an angle that's going to happen, obviously, and then coupled with a shorter stroke. So it just maintains the rod as straight as you can throughout the whole, while the crank's spinning.
All right. The dart block, on face value, well, we haven't actually talked about power levels so far, but on face value, I would have thought that probably the dart block was maybe an unnecessary expense with this particular combination. So, first of all, what is the power level, and am I right or wrong?
Yeah, so the dart block, it just gives you that structural rigidity down there, especially when you're swinging things around, and more so, more of a drama with the aluminium blocks is when you spin them up and rev them, you always see main cap walk. So the dart block it's not even something we need to worry about. And also the deck surface being so much stiffer, it just really helps keeping the head gaskets in and all that. But in saying that, definitely this type of power, we could have made an iron block or even an alloy block for that sort of thing. And I forget.
The actual power level?
So the actual power level makes 800 horsepower at the hubs.
Okay, I mean, it's definitely not messing around. Also, in terms of that shorter stroke crankshaft and the ability to rev, what are you revving it through to?
Yeah, so it spends most of its life pretty well at 8,800, and we spin it to 9 when we need to, but 88 just makes you feel better. 9,000 sounds like a lot, doesn't it?
I mean, it does sound like a lot, and that's because it is. Yeah, I mean, that is definitely getting up there for an LS-based engine. All right, cylinder heads. Again, there's a bunch of options there. What are you running?
So again, something a bit unconventional, what people would be used to. We've actually got an LS1 head on it. And the reason for that is they're like CNC ported and all that, so they're as good as they can be. The reason for that is with the solid roller and everything and spinning it up, we just want to keep that valve as light as we can. Sure. So without building a $150,000 engine with all titanium stuff and everything, keeping budget somewhat in mind. It's got a hollow stem stainless intake and an Inconel exhaust, and just keeping that head diameter smaller, it just helps with keeping the valve train as light as possible.
Again, in terms of the options there, I imagine most people would reach for the rectangular style port later model LS3 heads. In terms of the difference, I don't know if you've got numbers. If you could go to that rectangle port, again, CNC ported, all of the best of the best, what sort of power difference would you expect to see between the LS1 Cathedral port and the later rectangular port?
Oh, there'd probably be 150 or so, I guess.
And not insignificant.
Yeah, not yet. Definitely noticeable. Yeah, these are got like larger than standard LS1 valves and stuff, but that rectangle port, it's hard to beat. They just flow unbelievable for what they are.
All right, the exhaust manifold, we need to talk about that. Obviously, that's another standout, and I'm going to assume that 8-into-1 here is more a form over function than a requirement for power.
Yeah, 100%. We just wanted something obviously that sounds good and looks really cool as well. Maybe if we had have gone like a equal length sequential firing deal, it might have sounded a bit different or a bit better, but it sounds pretty good for what it is. And it just sounds cool and looks cool. Is all it's about.
I mean, I haven't heard it yet. I absolutely want to, but we saw this on the trailer pulling up to World Time Attack, and absolutely had to have a chat and find out more about what makes it tick. So, look, Mitch, great to get some insight into it. Thanks a lot for your time.
Perfect. Thank you.
That video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.